All right, we're going to talk about lesson 4 today, graphical features and terminology. So a lot of kind of vocab today as we look at functions and learning to read some things involving graphs. There's a lot of terminology associated with graphing a function. A lot of these words you can understand, you can wrap your mind around. So here's our first exercise 1. The function y equals f of x is shown graphed below. Now here's our first thing we need to look at. It says over the interval -7 is less than or equal to x, which is less than or equal to 7. What in the world does that mean? Well, that means that we're looking at the x's, right? The x direction. So on the graph, on the x-axis, I'm going from -7 to 7. It means that I'm going to look at all of the x's in between -7 and 7. Notice there's no arrows at the end of the graph. We're just talking about what's happening with this graph over what we call that domain interval, over the interval from -7 to 7. Okay, now we can read that. We know what that means now. We've been working on those inequalities, that compound inequality all year. We understand what that means now. Okay, it says, find the maximum and minimum values of the function, state the values where they occur as well, the values of x where they occur as well. Maximum and minimum are just what they sound like. Maximum is what's the highest point the graph reaches. Well, if I look at this graph, the highest point is right here. So we say the max is, let's see if I count, 1, 2, 3, 4, 5, 6, is it 7? And the x value is -1 at that point. So I'm going to write there's a max at -1 and its value is 7. We could write it in a bunch of different ways, but let's give the coordinates of the maximum value. And then the coordinates of the minimum value, well, that's the lowest point on the graph, and that would be right here. And the coordinates of the lowest point, 1, 2, 3, 4, 5, would be -5, and I want to state that this is a minimum, -5, comma, -1. Okay? Next question, what's the y-intercept? And again, y-intercept means where is it crossing the y-axis? Well, here's the y-axis, and it's crossing right there at 1, 2, 3, 4, 5, 6. So our y-intercept is 6. If you want to put 0, 6 as the coordinates, that's fine too. The next question is a good one. Explain why a function can't have more than one y-intercept. Why can't there be more than one y-intercept and still be a function? Well, that would violate that vertical line test, right? For an input, there would be more than one output. So a function cannot have more than one y-intercept. Part C here says give the x-intercepts of the function. X-intercepts where it crosses the x-axis. Well, a function can have more than one x-intercept. That's fine. In fact, this one has 2. One at -6, I think, and one at -4. We're told here, these are also known as the function's zeros because that's where f of x is equal to 0, where the y value equals 0. Okay, so x-intercepts, sometimes we call zeros. And this next part says, would you characterize the function as increasing or decreasing on the domain interval -5 is less than or equal to x, which is less than or equal to -1? Well, let's see what that means. -5 in the x direction is here, and -1 is here. So what we're doing is we're looking at the function between -5 and 1, between when x is -5 and 1. So if I trace that function, what am I doing? Well, it's going up from left to right. So would we characterize that as increasing or decreasing? Well, if it's going up, we would say it's increasing. Okay? We always read a function like we read English, we read left to right. Part E says give one additional interval over which the function is increasing and give one interval over which it's decreasing. So let's see, it's also increasing. I see it going up from here to here. So where is that? Well, let's see. That's from when x is 2 to when x is 5. So my interval, I would write from 2 is less than x is less than 5. Now there's debate in the math community about whether we should include the 2 and include the 5. I think don't include them, but I would accept either answer. How about an interval over which that function is decreasing? Well, decreasing means going down. So where could I see that function going down? It's going down in a few places. I'll go with over here on the left side. It's decreasing from here to here. So what are those x's? From here to here. Now I need to pause and count. I think I would say, we want to go number line order. So -7 is less than x is less than -5. So again, one of the big takeaways for this lesson is being able to use those compound inequalities that we've talked about for a few months now, okay? So the idea of reading left to right, what are the x's left to right? It's a little complicated. We will get used to this. Now the next part of this says the following points are known as turning points. What is a turning point? Well, let's take a look at the graph and see if we can figure out what that means. I think you'll understand this when you see it. The point -5, -1, well, that's right here. The point -1, 7 is here. The point 2, 2 is here. And the point 5, 5 is here. Those are called turning points because it's turning from decreasing to increasing, then from increasing to decreasing, from decreasing to increasing, from increasing to decreasing again. And the question says, each can be classified as a relative maximum or a relative minimum. That means relative to the points around it, is it the highest point or the lowest point? That -5, -1 that I see on the graph right here, that's the lowest point compared to the rest of the points around it. That's called a relative minimum. -1, 7, that's the highest point compared to the ones around it. That would be a relative max. 2, 2, lowest point, relative min. 5, 5, highest point, relative max. Okay, so minimum or maximum just means highest or lowest. This point 2, 2 is not the lowest point on the graph, but it's the lowest point compared to the ones around it. So we call it a relative min as opposed to an absolute min. All right, this next page, we're going to talk about this piecewise defined function again, okay? This is a little complicated. Here's what I want you to do. Our dividing point here is at 1. So I'm going to draw a line. Let's see, less than or equal to 1, greater than or equal to 1. So let's do a line right here at the 1. And I want you to use that x plus 3 for when x is less than or equal to 1, and 6 minus 2x when x is greater than or equal to 1. And let's get those points and put them on the graph, okay? And once we get those, we'll answer the questions down below. So hit pause, do those calculations, and try to graph it, and then we'll answer the questions below. So I filled out my table here. I do want to make a point, though. This is kind of a weird function because they've put both of those points at 1. What that usually means is that at the value 1, we get the same thing for either piece of that function. So let's see. I evaluated x plus 3 when x was 1, and I got 4. If I put 1 in here as well, and 6 minus 2 times 1, I also get 4. So I'd have 1, or I'd have 4 no matter what. No matter which piece of that piecewise function I used. So I'm going to plot my points. So I plotted those points and then I connected them, okay? And we can see there's a turning point there, right? It goes from increasing to decreasing. Again, these piecewise functions are a little bit weird. We can handle them. They're more of an Algebra 2 topic for us than they are for Algebra 1, but there's no reason we can't look at them in Algebra 1. All right. Question B says, state the zeros of the function. Well, zeros, again, are the x-intercepts. So the x-intercepts would be here and here. X-intercepts would be at -3. I'll put -3, 0, and 3, 0. Now, we could say the x-intercepts are -3 and 3. That's fine, too. I like to write the coordinates to remind myself that the coordinate points are... or that the x-intercepts are coordinate points. They're located on that axis where the y value is 0. Next question says, state the function's y-intercepts. Well, the y-intercepts would be along the y-axis. And again, we talked about how there's only one y-intercept. It's right there where it crosses the y-axis at 0, 3. Next question says, give the interval over which the function is increasing. Well, that means where is it going up? From where to where? And when we talk about intervals, we're talking about kind of along the x-axis. It's going up from here to here. So it's increasing, it's going up from there to there. But what we want to look at is across what x values is it increasing. Well, it's increasing from when x is here to when x is here. So from when x is -4 to when x is 1. And we write that specifically with one of those intervals. -4 is less than x is less than 1. And again, we could make the case that we should include the -4 or that we should include the 1. I usually don't include them. So in other words, a less than or equal to, I will accept whichever one you give me. But we should be able to read that now, right? We're going from here to here. It's kind of like we've gone from a 2-dimensional number line to a 3-dimensional number line, but we're still looking in the x direction from -4 to 1. Next question says, when is the function decreasing? Well, it's decreasing when it's going down, and it's going down from here to here, but we're looking along the x direction. It's decreasing from 1 to this point, which is at 4. So we would say it's decreasing. 1 is less than x is less than 4. Okay, so we talk about those intervals, and we can read those now. We've been working on those all year long. Next question, give the coordinates of the one turning point and classify it as either a relative maximum or a relative minimum. Well, it's a turning point when it goes from increasing to decreasing or decreasing to increasing. And in this case, that would mean at the point it's turning from going up to going down. So we're looking at when it goes from here to here, that turning point is this point right here. So 1, 4. And because that's at the top of a bump, that would be a relative max, relative maximum. Okay? And the last couple questions here say, use the graph to find all solutions to the equation f of x equals 2. So again, what we do there is we look at when y is 2. So I'm going to kind of sketch in here. Here's where y is 2, and that happens twice. It happens when x is -1, and it happens when x is 2. Okay, so again, we draw that kind of horizontal line. It says illustrate your solution, and that's exactly what I just did. Drawing that horizontal line allows me to see where that thing that I drew, that function, goes through y equals 2. Then it says state the interval over which this function is positive. And how can you tell this quickly from the graph? Well, it's positive where the graph is above 0. At the underneath that y-axis, it's negative. So let's see, it's positive from here to here. And I believe that's from when x is -3 to when it's 3. Now I'm not going to include the 3's in this case because at -3 and at 3, the function is 0, which is not positive. 0 is not positive or negative. So we're learning to interpret that compound inequality that we've been talking about for a while. All right, work on the homework, and then, again, circle them, any questions you have trouble with. All right, and we'll talk about them next time. And that's it for today, guys. All right, we'll do lesson 5 using some tech, and then lesson 7, we're skipping lesson 6, and then we're done. All right, have a great day, guys. Bye-bye.